Welcome to the video for testing divisibility by 3, 6, and 9. We're going to break numbers apart much the same as we did in the video on divisibility by 2, 4, and 8. We're going to be using place value. So if you don't feel comfortable with place value, watch that video. We're also going to be using distributive property when we look at 3, 6, and 9. So there's also a video on the distributive property. If you don't feel comfortable with the distributive property, watch that video before you watch this video, and then hopefully you'll be able to figure out how to tell if something's divisible by 3, how to tell if it's divisible by 6 and by 9. First thing I'm going to do is divide up my 279 into the place values, much the same as I did in the video on divisibility by 2, 4, and 8. So I'm going to call that 2 times 100 plus 7 times 10 plus 9. And I'm now going to set up so that using my distributive property, I'm going to call this 2 times 1 plus 99 plus 7 times 1 plus 9 plus 9. And now I can use my distributive property. 2 times 1 is 2 plus 2 times 99. Order of operations, PEMDAS says I have to do the 1 plus 99 first. Distributive property says there's an exception. I can do the multiplication first if I multiply by both. And I'm doing that here. So I do 7 times 1, which is 7, plus 7 times 9, plus 9. So I look at that, and now I'm going to clarify that even a little bit more. I have 2 plus 2 times 11 times 9. I'm going to call my 99 11 times 9 plus 7 times 9 plus my 9. So now I know that I have 2 plus 22 times 9 plus 7 plus 7 times 9. So I'm going to plus my original 9 that came from my ones place. So I'm going to take that, running out of room, and I'm going to group it into things times 9. So I have my original numbers, 2 plus 7 plus 9 plus 22 times 9 plus 7 times 9 is 29 times 9. So if I try to divide by 9, I can take out 29 nines, so I actually have 18 plus 29 times 9. So now I can look at this and say, well, now I've got 2 more 9s here. My 18 is 2 times 9. And I can say that 29 plus 2, I can actually go backwards from the distributive property here, and I can say 2 plus 29 times 9 Distributive property goes both ways. You can multiply inside the parentheses. You can take a number outside as long as it's the same number multiplied by both. So now I can say 31 times 9 equals 279. You can check that if you'd like. In terms of divisibility, though, I don't really need to get that 31. I just need to take out a bunch of 9s and see what I have left over at the end. So if I want to decide if it's divisible by 9, I really just need to look at the sum of the digits. 2 plus 7 plus 9. I know everything else is going to be divisible by 9. So when I'm checking to see if it's divisible by 9, I add up all the digits, ignoring the place value. So I just do 2 plus 7 plus 9 equals 18. I know it's divisible by 9. I did the 9s first because you saw the 9s are kind of easier to figure out. I'm going to do the 3s now as well, kind of using the same idea. To see if this is divisible by 3, I'm first of all going to break it up as we did before. I'm going to say 2 times 100 plus 7 times 10 plus 3. And I'm going to call that 2 times 1 plus 99, which I'm going to call 9 times 11, or 3 times 3 times 11. And you'll notice that's the second term inside the parentheses. Instead of writing 99, I wrote 3 times 3 times 11. Plus 7 times 1 plus 9, but instead of 9, I'm going to write 3 times 3. Because we're really worried about the 3's now. Plus my 3. So now I distribute 2 times 1 is 2. So I multiply the 2 times the 1. And I'm going to multiply 2 times 3 times 3 times 11 using the distributive property. Knowing that if I don't want to do my parentheses first, I can multiply first. I just have to multiply both the things that are added. Now I'll do 7 times 1 plus 7 times 3 times 3 plus my original 3. And so now I'm going to regroup it so we can think about it. I'm going to take my 2 plus my 7 plus my 3, which were the original numbers. I'm going to group them first. And then I'm going to look at the other terms in terms of something times 3. So 2 times 3 times 3 times 11. I'm going to change that to 2 times 3 times 11, or 6 times 11. 66. And then I'm going to multiply by the other 3. So I have something times 3. If I want to divide by 3, I have to take out a lot of 3's. I have to keep subtracting 3's until I can take out no more 3's and count how many 3's I have subtracted. I'm going to say 7 times 3 times 3 is 21 times 3. So I've got my original digits, 2, 7, and 3, plus 66 times 3 plus 21 times 3. Again, I'm going to go backwards. I'm going to take the distributive property backwards. I'm going to take 66. So 66 plus 21 times 3. If I look at that, the distributive property tells me I could take my 3 and multiply it by the 21, and then also multiply it by the 66. So I know that the second thing I've written is equivalent to the first. And I've still got my original numbers. So if I look at dividing now, I have 87 times 3 plus my original numbers. So if I'm trying to answer the question, how many 3s are there in 273? I know that's 887 times 3, plus however many 3s are in 2 plus 7 plus 3. Actually, I think it's time to go ahead and add those. 2 plus 7 is 9, plus 3 is 12. And to do my division, I need to change my 12 to 4 times 3. And then I still have my 87 times 3. So I can say that taking that 3 back out again, going backwards from the distributive property, 87 plus 4, or 91 times 3, equals 273. You can put that in your calculator. I'm going to check it real quick. 3 times 90 is 270 because 3 times 9 is 27. 3 times 1 is 3. 270 plus 3 is 273. So I've divided it by 3 by taking out a lot of 3's to see if I was divisible by 3. I didn't really need to worry about this part of the number because I knew that part was going to come out divisible by 3. All I needed to worry about was the sum of my digits. Where I added up 2, 7, and 3, since that was divisible by 3, the rest of it had to be divisible by 3. Interesting story. Nikola Tesla, very interesting person, basically invented alternating current. If you're a Big Bang Theory like me, Big Bang fan like me, they had a nice episode on Nikola Tesla. He would only stay in hotel rooms where the number was divisible by 3. So for a while, he actually stayed in Colorado Springs. He was actually in Colorado for a while. But the hotel he stayed in had a number that was divisible by 3. Let's look at dividing by 6 now. First of all, if I add my numbers using the idea of adding digits, 1 plus 2 is 3. So I know 12 is divisible by 3. I also know it's divisible by 6, but it does not add up to 6. The digits do not add up to 6. If I have 15, 1 plus 5 is 6, but 15 is not divisible by 6. It's interesting. 1 plus 8 is 9, so we know that's divisible by 9. It's also divisible by 6, though. 2 plus 1, 21. 2 plus 1 equals 3. We know it's divisible by 3. We know it's not divisible by 9 because it doesn't add up to 9. And it's obviously not divisible by 6. 24, though, 2 plus 4 equals 6. And 24 is divisible by 6. 6 times 4 is 24. So sometimes if it's divisible by 6, it doesn't add up to 6. Sometimes it adds up to 3. Sometimes divisible by 6, numbers divisible by 6 add up to 9. And sometimes they add up to 6. So we can't look at the sum of the digits being equal to 6. That doesn't tell us it's divisible by 6. But hopefully you notice a pattern here. Um, 12 is the digits add up to 3, but it's divisible by 6. So we can divide by 6. 15, they add up to 6, but it's not. 18, they add up to 9. It is divisible by 6. 21 is not divisible by 6. They add up to 3. 2 plus 4 equals 6. And 24 is divisible by 6. So really, hopefully you see the pattern. If it's divisible by 6, it is divisible by 2 and divisible by 3. So to see if it's divisible by 6, you add the digits. If the digits are divisible by 3, you look to see if it's an even number, if it's divisible by 2. So it's interesting the way the pattern goes. If you have 12, they add up to 3. You add 3 more, they add up to 6. You add 3 more, they add up to 9. You add 3 more, they add up to 3. You add 3 more, they add up to 6. We add another 3, we get 27. That's divisible by 9. So there's an interesting pattern there, but we really can't use that pattern to determine divisibility by 6. We just have to decide if it's divisible by 3, and then if it's divisible by 2. If both of those are the case, then it is divisible by 6.